Okay, so looking at our note sheet, we're talking about congruent triangle proofs. So first thing we're going to talk about is SSS, which is side, side, side. So in this case, and that is a congruence theorem, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are in fact congruent. This is what you're going to want to star or highlight, okay? Now, if we looked at this example, A, B, C with D, E, F, we see that AB would be congruent to DE, and BC would be congruent to EF, and then AC would be congruent to DF. Because of that, we would then have the congruency statement, triangle ABC would be congruent with DEF. Now we're going to kind of jump around here a little bit, only because I want to, make sure we're getting all the information. I would like you guys to turn to the next page where it says SAS. Is anybody still writing this down before I move on? Okay. All set? Okay. All right, so let's scroll down to SAS. So in this case, if we take a look, this is side, angle, side. If two sides and the included angle, that is so important. The included angle, that means an angle that is kind of between the two congruent sides of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are in fact congruent. So we would state here that for triangle ABC and DEF, we would have AB congruent to DE. We would have angle B congruent with angle E. Now also remember that you might want to use three letters for a lot of these. Okay, three letters might be important. It just so happens these are kind of separated right now. And then BC is congruent to EF. So then we would state triangle ABC is congruent to DEF, and we can state by side, angle, side. Anybody still writing this down? Okay, take a look at your foldables. I want you to look at side, 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 and side, angle, side. If you look, they're telling you that yes, you can prove triangles congruent using those two, and it shows you kind of an idea of how it's supposed to look. All right. I want you to keep those open while we turn to the next page where we go to triangle congruency. We're going to get back to the proofs in a few minutes. Right now, let's just look at triangle congruency. So the directions state here, state whether the triangles can be proven congruent, if possible by side, 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 or side, angle, side. Include a congruency statement for all congruent triangles. So if we take a look here, we see that QY is congruent to KC. We also see that angle Y is congruent to angle K. And we also see that TY is congruent to KP. So can these two be congruent? Yes or no? Absolutely they can. By what? Good. Side, angle, side. Very good. Emily, I'll send you at the end. And so what we're going to do here is we're going to write the congruency statement. We're going to state, and we have to be very careful. Remember how we name these triangles. We're going to put triangle QYT is congruent to triangle CKP. And we would state by side, angle, side. Now, you notice how like before with proofreading, I'm like, oh, make sure you write it out, right? You can state these as side, angle, side, SSS, or SAS, side, 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 SSS. I am fine with that. We get to similarity, there's going to be a little bit of a change, but nothing huge, okay? Questions on that one? All right, let's take a look at number 2. And this is going to review some stuff for us that's on that sheet that I gave you today. Here we have AD is congruent to BC. So AD is congruent to BC. We also have AB is congruent to DC. Does anybody else see what else could potentially be congruent here? Go ahead. No, do we have any evidence of that? I'm sorry? Is it isosceles? Okay, what do you think? AC and CA, why? All right, it's the same thing, so very good. And we're going to state the reason, okay? So we could state this is congruent to itself. So you could say AC is congruent to AC or CA, it does not matter. What's the property for that? This is from topic 1, and we talked about it, but never really applied it. And I said, wow, guys, it's going to be so important once we get to triangles. It's on your sheet. What is it? What is it? Not symmetric. You're looking in the right spot, though. Not property of congruence. And that's a definition of congruence. So, what is it? Reflexive property. Yep, this is the reflexive property. That is important to know now. Super de-duper important to know now. Okay, so these two triangles end up being congruent. How? By what? Side, side, side. All right, so in this case, we're going to state that triangle. Again, be careful with how you name them. A, I'm going C, then D. So I'm going from here to here to here to name those. So this identifies what parts I'm lining up with what. Is congruent to triangle. Now I have to do the same thing, but for this triangle. Now I went down this way, okay? But I got to make sure the angles line up. So I'm going to start with C, and then I'm going to A, and then to B. So I covered this congruent side, this congruent side, and then that covers the other one by definition. And I'm going to put by, side, side, side. Questions on that? I want us to take a look at number 6 next. So let's take a look at that. Now, if we look at this, we see that we have parallel lines here, which means we have a transversal. So do you think we're going to have to do something with these angles? Nod your heads, yes. Yes, Mrs. Smith. We're going to have to do something with the angles. Absolutely. All right, so the first thing I'm going to do is identify what I have. I see that JD is congruent to ME. So here's JD, here's ME. I'm just going to kind of color code this just to make my life a little easier. And then I have DA is congruent to AE. So there's this guy and this guy congruent to each other. Now I'm looking at this, and remember, for side angle side, I'm not going to have another side here. There's nothing here that proves another side. They're not giving me any tick marks. There's no reflexive property. So I need an included angle, which helps the colors kind of help me limit that included angle to this guy and that guy. Did you guys see that? If you have colored pencils, especially if they're erasable, or colored gel pens, again, erasable, use them to your advantage for these, okay? So you understand what you're proving. All right, so in this case, so if I have this is parallel to this, and this is my transversal, I can state that angle D is congruent to angle E, but how? Good. Alternate interior angles. Theorem. So now that I have this, I can state, again, naming is important. Don't forget about that. I'm going to go J to D to A is congruent to, I'm starting with E in the next triangle because these are the, I'm sorry, I'm not starting with E. I'm starting with M because these are the congruent angles there. So triangle M, and then I'm going to E because D and E are congruent, and then to A. And this would be by side, angle, side. Oh, you just brought up a really good point. No, it's not side, side, angle. I want you guys to open the foldable of side, side, angle. What does it state? Is side, side, angle congruent? No. That is on there on purpose because that cannot be used. There is no side, side, and some sort of random angle that you can apply. This is side, angle, side, which means you have to have that included angle. That is the difference. Okay? Side, side angle is not a thing. Please do not make it a thing. Okay? All right, what I want you guys to do is I want you to work on 3, 4, I actually just work on the rest. Identify things, see if they work out. Use colors if you need to. I'm going to give you a couple minutes to just identify these before we move on to the proofs. All right, show of hands who's still working on these. Anybody? Okay, I'll give you another minute.
Wait, so what angles did you say? On both sides. Where was it?
Wait, what? Who's talking about your shirt, Izzy? About
She sent us picture, Dave. I was like, oh.
it's a cute shirt. I like the whole vibe. You got plaid pants on. I'm like, seriously. Yeah. It's very California. Oh my. EMSA can't come soon enough. You didn't send it yet, did you? Okay.
They don't let you send it until actually today, I think. So
Okay.
or maybe it's December. I think it's December.
Okay. I'm just checking. I've been looking for it.
I was like, that's like the last thing I have to do for my application. So I got a little like, I was like, okay, last thing to do is just tell them a month or two in advance. It's okay. It's alright.
I show hands who's still working on these.
Okay. You're gonna have no friends. They're all gonna be weird until you say it.
Wow. All right, let's go over this before we talk about Cassie's future social engagements. All right. So let's take a peek at these. So we did 1 and 2 together. 3 should have been side angle side. And minus the fact there's supposed to be a triangle symbol here. Triangle JMK is congruent with triangle LKM. Now remember, you could have had MLK and then KJM. That's totally fine as well. Okay, you just have to make sure that all the corresponding parts line up. 4 is not congruent because again, we have side angle. That is not a thing. Yes. like you can like this. If you look at 2, side, 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 right? If you look at 6, we had a side, angle, side. Like I can literally point to it and they're like right there. In this case, if I look, I have a side, and then I have this random angle here. It's not going to work. It's all about position. Yeah, and this one's not. It has to be like for this to work, it would have to be at angle T and angle S, and it's not there. Does that make sense? Yes. Think of it like this. Abdul, go like this. 2 congruent sides. The angle's got to land right here. Has to be between the angle has to land between the 2 sides. Does that make sense? That one does not. Does that help? That help? Okay. Okay, number 5, side, side, side. Again, EF, you're using that reflexive property. It's empty? Uh-huh. All right, 6 we did together. 7, not congruent. Again, you have side, side, and that random angle. Now 8, if you take a look, it is side, angle, side because you have vertical angles right here. So this is those would be congruent by the vertical angles theorem. Okay, so again, P sign, right? Your P sign would land like between Q, P, R, and T, U, S, but the angle is not at P or U. Do you see that? Abdul, yes. Right here, if you look, we have vertical angles. So that rule still applies. Does that make sense? So this would be side, angle, side, because again, we have the P sign, right? And the angle's right there. Evan, you had your hand up. What's up? If you remember, let me know. Okay. All right. Let's start warming up with proofs. Are there any questions on this before I move on? All right, head back to the first page. All right, so here's a nice little proof warm up for you guys. All right, so here it is. Now they listed everything and then we're just listing the properties. Again, highly recommended you use colors and highly recommended that you mark things, all right? So the first thing they're saying is given PQ is congruent to ST, QR is congruent to TR, and R is the midpoint of PS. Prove that triangle PQR is congruent to triangle STR. Remember that this has to be your final statement. So the first thing we have is PQ congruent to ST. So I know this is congruent to that. That is given to me. QR is congruent to TR. So here's this. Again, that's also given to me. R is the midpoint of PS. Hey, wouldn't you know it? That's given to me also. Okay, now they're saying PR is congruent to SR. So here's PR. Here's SR. Those end up being congruent. Why? No. I'm sorry? R is a midpoint. So this is by definition of a midpoint. And therefore we have a side, side, side. So how are these two triangles congruent? SSS. It's the SSS triangle. Who's still writing? All right, number 2. Again, let's talk about this. JL is congruent to NM. That's given to me. So this is congruent with that. So that's given. I also have K as the midpoint of JN and LM. That's given to me also. All right, so I'm going to stick with that same color. They're saying JK is congruent to NK by, yep, not reflexive property. Yes. Definition of a midpoint. And if we look, we have LK is congruent to MK. How, Evan? Sure. Yep. Definition of a midpoint again. Very good. So therefore, these two triangles, JKL is congruent to triangle NKM. How? SSS, side, side, side. All right. So are we getting the vibe of the document, how the givens are kind of split up? All right. So let's take a look at number 3. Uh-oh, it's blank. Do you think you're going to have blank ones on your test? Shake your head up and down. Yes, it's going to happen. All right. So here I'm going to put AC is congruent to AD. That's given to me. So AC is congruent to AD. The next thing I have is that CB is congruent to DB. That is given to me also. So now what do we see? Yes. For what? Yeah, so we're going to say AB is congruent to AB. That is by your reflexive property. So this is congruent to itself. This leaves me with the final statement because I have 3 sides. So I have triangle A, B, C is congruent to triangle A, B, D. What is the reasoning? Side, side, side. Yes. Just give you something harder? Huh? Oh. I see. All right, let's take a look at number 4. All right, so number 4, if we take a look, we have JM is congruent to LN. That is given to us. So we have JM, LN. The other part that is given to us means that angle JMN is congruent to angle LMN. So JMN right here is congruent to LNM, which is right here. So that's given to us. Now they're saying that MN is congruent to NM. How so, Izzy? Reflexive property. Very good. So this is congruent to itself. Now look at this. Is there a peace sign here with an angle in between? Yes, there is. So this ends up being what? Side angle side. Please do not call it SAS. Yes. I'm sorry? The reflexive property basically shows that that line works for both triangles. That's why it's congruent to itself. Good question. Any other questions? All right. Next proof. Let's keep going. All right. So the thing that they're giving us here is that AB is congruent to CB. So AB congruent to CB, that's given to me. The next thing they're saying is that BD bisects ABC, that's given to me also. Now I'm going to work with that idea of the bisector. So they're saying if this is bisecting this larger angle here, they're stating that this is congruent with that. So who can tell me what's the reasoning for that? Good. Very good. Definition of an angle bisector. And then they're telling me that DB is, or BD in this case, is congruent to itself. How? Reflexive property. And then these two triangles are congruent using, don't call it SAS. SAS, side, angle, side. I'll give you SAS if you call it SAS. It's like nails on a chalkboard, guys. Don't do it. I want you guys to take a minute and I want you to do 6 and 7 on your own. Just name those properties.
How is 5 SAS?
If you look, side, angle, side. Does that help? If you identify the peace sign, the angle's there.
What is it?
Bisector.
Stonehurst.
Did you say Stonehurst?
It's like the first thing that keeps my head.
What is that?
Did you just read the Scarlet Letter or something? Or
Wait, would you go for 3?
Oh, that's when you see SAS, you gotta go.
Wait, what?
That's a lie. It's actually opposite.
Every time you say actually something oh my, your brain is like running right. No, with vertical, like,
yeah, we're gonna do that.
oh my.
Yeah.
I don't know why. What do you guys do? That's what my sister said. Bring back a chicken sandwich. She better have a pickle. I said, oh, you have a pickle. No, yeah. The pickles, I know. They pickles. Yeah. Dude, chicken sandwich pickles ruined chicken sandwich.
Are you done with this?
Oh, yeah.
You are? Both? Yeah. 6 and 7? The properties can only be reviewed if you do it. We need to do it. For you guys? Second hour, you guys are Thursday.
Thursday? Before when?
Before winter break, yeah. Final exams are the 20th, 21st, and 22nd of December. So you guys are pretty, like, it's not like middle school. You're not gonna have anything fun, sorry. I know. I get you, Cassie. Believe me. I love to watch a movie. The COVID years were bomb diggity because I was able to show them. No. When we came back, I'm talking about, like, I was able to show them, like, you know, they voted on a movie, watch Back to the Future. It was fun. All right, who's still working on 6 and 7? All right, I'm giving you like 30 more seconds. Whoops. All right, here's 6. This should be vertical angles theorem. Do not forget the theorem part. That is very important. It's not just vertical angles, it's vertical angles theorem. Questions on 6. Let's take a look at 7. Questions on 7 that I can address. Don't forget theorem after alternate interior angles theorem. Remember, those are still theorems and there's a postulate there. Do not forget about those. Alternate interior angles, that should be a theorem, right? Yeah, that's a theorem. The postulate. Wait a minute. Which one was the postulate? I'm trying to think for this book. I'm stuck on the old book. I'll double check which one's the theorems and postulates. No, those are not. I have another foldable I have to give you guys, but I gotta line it up. Evan? I think that's a theorem, if I recall correctly. How we get alternate interior angles. All right, so if we take a look, they're giving you this information, and they told you in the given that HI is parallel to GJ. So then you just have to work with the transversal at that point. Does that make sense? All right, any other questions on 7? All right, last one, go to 9. The rest, guys, are all going to be for extra practice if you choose to do it. Okay?
We love and appreciate it.
No, I didn't say extra credit. I said extra practice. I don't recall the word credit coming out of my mouth. What you think you hear and what you actually hear are two different things. All right, so we're going to start with AB is congruent to CD. That's given to me. They're saying AB is parallel to CD. So AB is parallel to CD. Good job, Izzy. Proud of you. All right. So I'm just going to put little arrows here for those so that I know that those are parallel. It is okay to mix the parallel with the congruency symbol. And then they're saying D is a midpoint. Izzy, what is that one again?
Wait. What?
It's okay, I got it. Given. All right, number 4. Now, so here we are. We have all this stuff, okay? Let's focus on something that's easy to deal with. In this case, if D is a midpoint of BE, that means this is congruent with this. So BD is congruent with DE by definition of a midpoint. So we have two sides, and they're telling us, they're giving us parallel lines. So do you think we're going to do something with the angles? Yes, absolutely. Okay. And that's going to look like the following. So I'm just going to kind of draw the parallel lines. And I'm going to find the transversal. In this case, the transversal is going to be right here, and I can focus in on this angle and this angle being congruent. So I'm going to state that angle ABD is congruent to angle CDE, and that would be by what? No, angles. The answer to this corresponding angles theorem. Very good. And now we know that both triangles ABD are congruent to triangle CDE by, what is it? Side angle side. Don't do it. Don't do it, Izzy. All right, 10, 11, and 12 are extra practice. Now look at the homework. There are a total of 10 problems. Identification and lots of proof writings. The last two are filled in. You are required to do all 10. Yeah, so you can do all 10. I'm sorry to hear that. I'm sorry. I'm very sorry to hear that. Ouch. This is going to be a very difficult assignment for you. So you have all 10 for homework, and I do highly recommend you complete 10, 11, and 12 for extra practice. I'm not going to lie to you guys. The more you do, the better off you will be, okay? All right. Those of you watching at home, have a great day.